In this video, we will talk about relationship between short-run cost curves and long-run cost curves. Even it will be clear to you why this long-run average cost curve is of this particular shape, why it is flatter, and relationship between average, total and marginal cost curve you will come to know. This is our short run average cost curve and our marginal cost curve cuts it on its minimum point. Here we are using our quantity. So this is about short run average cost curve. How we move from short run to long run, I am explaining the whole process here. I am going to draw a long run average cost curve, but with the help of short run average cost curves. If this is our short run average cost curve, quantity produced. If we are producing this much of quantity, our plant, I mean in short run, we are using a plant of production and it is average cost of that plant, and our average cost is minimum. When we are producing this much quantity, our average cost is minimum. And our plant is perfectly utilized. If we produce a less quantity, our plant is underutilized. If we produce more, our plant is overutilized. Suppose we have to produce this much of quantity, so our average cost is very high. You can see here our average cost is very high. If this increase in your output is permanent, I mean to say every time you will be producing more because of some reason, maybe increase in demand in market, and that is a permanent increase in demand, it will be in future also, so you have to produce more, but your average cost is very high. I mean to say per commodity cost of production is very high. So you can do one thing, you can set up a new plant. So in long run, you can increase your production capacity by any amount, maybe 2%, 3%, or maybe 2 times, 3 times you can increase. So suppose you are setting up a new plant of production. This is short-run average cost curve of your new plant. You can see that new short-run average cost curve is lower, or it is lesser than the previous one, because you are having experience of running one plant, setting up of one plant already. So your new plant will be more efficient. I mean to say your new plant will be having lesser cost. So this much of output now you can produce in your new plant, and your average cost will be very low if we compare it with previous point. Again, if you are producing this much amount, even more, your average cost will be again very high. Again you will set up a new plant. So here is your new plant. So every time new plant is more efficient because you are having experience of running the plants. So this is example when you are increasing your production capacity 2 times and 3 times. This is the line on which you will be operating. After this point, you will not operate on your first plant. You will start producing on your second plant, and after this point again you will not produce on your second plant. You will start producing on your third plant. So you will be operating on this dark line to produce any amount or any quantity of your output. But this is example when you are increasing your production capacity 2 times or 3 times, there will be many other options between these two plants also. When you are increasing a capacity of production by 1%, 2%, 3%, so if we consider all the options between these two options, our this line will not be like zigzag, our line will be smooth like this, and it will be like this. So our line will be smooth like this. After some time, it will be difficult for you to control too much production which is going on. You are not able to supervise properly, and there are many problems occurring. Those are called diseconomies of scale. Uh, because of that, now your average cost will start increasing. Again, there will be some short run average cost curves which are touching this line. So this is your long run average cost curve, and these are short run average cost curves. Now we will talk about a relationship between short run cost curves and long run cost curves. When your LAC is decreasing, all SACs are touching it left side. When it is increasing, all the SACs are touching it right side. This is first point. Second point, when your LAC is minimum, there must be some SAC, and on same point there is minimum point of SAC also. This is second point. Third point, as it is covering all the SACs like an envelope, that's why it is called envelope curve. Next point, SAC shows minimum possible average cost to produce any amount of output. So any level of output you are producing, LAC is minimum possible cost. It is not true for SAC, because you can see here that to produce this much quantity, your minimum possible cost is this, but on SAC it was so high. So this is not true for short run average cost, but this is true for long run average cost curve, that it shows minimum possible cost to produce any level of output. Okay, now next point. I have to draw a separate diagram. Okay, I'm trying to use this diagram. This is the point where your short run average cost and long run average cost both are touching. But interesting point is that on same level of output, even their marginals are equal. But those are not touching, but they are cutting each other. How it is possible? Let me show you. This is short run marginal cost curve. This is short run marginal cost curve, and on same point your long run marginal cost curve. This is long run marginal cost curve. Here is long run marginal cost curve, and both are cutting on this point. So on this level of output, your averages are same, your marginals are same. And even one more interesting thing is that on same level of output, even their totals are same. This is your total cost in long run. So this is long run total cost curve. This is short run total cost curve. So both are touching each other here. So even their totals are also same. So this is interesting point here. So these curves I have drawn according to your classical economists, but according to modern theory, their average variable cost is like this. According to modern theory, there is some reserve capacity in this plant. I mean to say, if we are producing from this level of output to this level of output, there is no increase in your average variable cost. But according to traditional theory, it is U-shaped. There is only a single point when it is minimum. If you produce less or produce more, immediately your cost will be increased. So there is only a single minimum point. But here there is a range where your cost is minimum. This is a difference between modern theory and classical theory in case of short run cost curves. Let's talk about long run cost curves. According to our traditional theory, long run cost curves is this U shaped, but this is very flat. It is flatter than that of in short run. But according to modern theory, yes, our LAC will decrease, but it will never increase because we learn by doing. We are getting more and more experience, and because of that experience, we will not allow our average cost. We will not allow our average cost to increase. So this type of average cost is in long run is according to modern theory, and its another name is learning curve. This average cost in long run is according to the classical theory, and its another name is envelope curve. So this is all about costs